Good morning, gentlemen. Today is Tuesday, June the 2nd, and today we are going to talk about section 15.4, which is entitled The First Postulate of Special Relativity. Now, we've been talking a little bit about frames of reference and how this all works together. And Einstein reasoned that all motion is relative, all right? And all frames of reference are arbitrary. It depends on what you want to choose. We've talked about this in the past, right? Remember the example of you riding on a school bus that's going 60 miles an hour up the Northway. If you walk toward the front of the bus at 2 miles an hour, well, relative to the bus, you're moving at 2 miles an hour. But relative to the ground below the bus, you're moving at 62 miles per hour. If you turn around and walk back to your seat, then relative to the bus, you're moving at 2 miles an hour again, right? But relative to the ground, you're now moving at 58 miles per hour. So that's what we mean when we say that frames of reference are arbitrary. What frame of reference are you talking about? Are you talking about the bus as your frame of reference, or are you talking about the ground as your frame of reference? Okay. The same kind of reasoning can be applied to riding in a car and looking out the window and looking at another car. Here's the thing. You have to imagine right now that you can't see anything else. There's no trees, no signposts, no lines on the road, nothing. All you can see is the other car. Now, if you're sitting in that car and you're looking out the window at the car next to you, all right, can you determine, if you can see nothing else, can you determine whether you're moving, the other car is moving, or are both of you moving? Now, if your car is moving at 60 miles an hour, but the other car is only moving at 50 miles an hour, it will look like you're going forward, right, at 10 miles per hour, right? 60 minus 50 is 10. If the other car is moving at 60 and you're moving at 50, then it might look like the other car is moving at 10 miles an hour ahead of you, all right? But you don't really know that. Okay, you could be moving at 70 and the other car could be moving at 80. You could be moving at 200 and the other car could be moving at 210. If you can see nothing else, then the only thing that you can determine is the other car's relative speed to your speed. Okay, so, and again, this takes a little bit of imagination. But this led to Einstein's idea of this first postulate of relativity. All right. And again, here's the two cars. If both of them are moving at 60 miles an hour, then they do not appear to be moving at all relative to one another. But if I made this one 30 miles an hour, and this one's 60, then the purple car would appear to be moving at 30 miles an hour relative to the red car. Now, what if I then made the other car go backwards, the red car go backwards at 30 miles an hour? Can you tell me how fast the driver of the purple car would think that he was going relative to the red car? Well, if the purple car is moving forward at 60 and the red car is moving backward at 30, then the relative velocity of the purple car to the red car is 90 miles an hour. Okay, this is the same reasoning why head-on collisions are so much more dangerous than a fender bender or that kind of thing. If two cars are moving at each other at 60 miles an hour, then they hit at a relative speed of 120 miles per hour. All right, that'd be like one car hitting a brick wall at 120 miles an hour. All right, there's NASCAR for you. So, in any event, in the words of Joe Einstein, the first postulate of special relativity goes like this: all the laws of nature are the same in all uniformly moving frames of reference. Okay. Now, what that means is that if all of the vehicles are moving at constant speeds, you can't tell which one's moving and how fast relative to the other. This is not true, by the way, for accelerating objects. Objects that are accelerating, you can actually feel the force of your acceleration or causing your acceleration to move forward. All right, so this is only true. This first postulate of special relativity is only true for objects that are moving with constant velocity, regardless of what that constant velocity actually is. Okay, fellas, that is all that I've got to say for today. So happy Tuesday, and I will see you tomorrow.